In this video I will give an explanation about the angle bisector of section 10.3. An angle bisector is a line that divides an angle into two equal angles. Here we see angle A, the blue lines make up angle A, and the red line divides angle A into two equal angles, as you can see by the little symbols right here. An important property of the angle bisector is that all points on the angle bisector have an equal distance to both of the arms of the angle. For instance, if I pick a random point, let's say this one, then the distance from this point to this arm is the same as the distance from this point to the other arm. The distance from a point to a line is always measured perpendicularly. That's why we see the perpendicular symbols here. And the little V symbols indicate that these little lines are the same length. So this point is the same distance to this side as to this side. And that goes for all points on an angle bisector. Now, how to draw an angle bisector yourself. Here we see two examples of angles. Let's start with angle A. Of course, an obvious way to do this would be to measure angle A. Angle A is an acute angle of 50 degrees, as you can see. So, if I make a mark at 25 degrees, halfway between, and draw a line from the angle onto the mark that I made, then I will have divided up my angle into two equal angles. But in mathematics, we like things to be precise, and measuring an angle isn't really precise. So a better way to do this would be to construct. And for constructing an angle bisector, you need your compasses. You can set the radius to any any distance that you like. My advice would be to take a rather small radius, 1 centimeter or maybe 2. We need to make a few arcs with the same radius, so make sure that once you've set it, don't change it anymore, don't touch it. So the first step would be to place the sharp edge on the vertex, angle A in this case, and make two arcs, or one big one if you like, as long as you get 2 points of intersection, one with each of the arms of the angle. Remember to not change the radius, the distance of the arms of the compasses right now. The next thing to do is to make 2 more arcs, one from each of the point of intersection we just made. So the first one here, and the next one with the sharp point on the other point of intersection. And the last 2 arcs intersect each other right there. If I now draw a line from the vertex through my point of intersection of the 2 last arcs that I drew, then this line will be my angle bisector. I can check it, of course. Remember, my whole angle A was 50 degrees, so each of these 2 little angles should now be 25 degrees. As you can see, that is indeed the case. So make sure that when you draw an angle bisector or construct an angle bisector like we did just here, is that when you're done, include symbols that indicate equal angles. Also, please don't erase the arcs that you used to construct your angle bisector. You have to leave them there. Now, it works the same with an obtuse angle. The first thing to do if I want to make an angle bisector is to take my compasses again and put the sharp edge on the vertex and make either one big arc or 2 small ones, as long as you get the 2 points of intersection right there. Then, without changing the distance between the arms of your compasses, make another 2 arcs, one from each of the points of intersection that you just got. Let's make the first one a little bit bigger to make it more obvious. Now here we have a point of intersection. If I were to draw a line from the vertex of B through my point of intersection, then this line is the angle bisector. Don't forget the symbols and do not erase the arcs. One more example. Here we have triangle PQR, And as you can see, 2 of the 3 possible angle bisectors have already been constructed. I've left the arcs there, and I've indicated that these are angle bisectors by using the symbols. The 2 angle bisectors intersect each other at point S. The question is, if I were to make the third one, the third angle bisector for angle Q, would my angle bisector pass through point S as well? Let's check. I go about it the exact same way. So I take my compasses and make an arc here, and I make an arc there. Use those 2 points of intersections for 2 new arcs. And then draw a line from vertex Q through the point of intersection of the last 2 arcs. Now, if I do that, you see that indeed, with a little bit of smuggling, the third angle bisector also intersects at the same point. Don't forget the symbols. Now, you're going to prove that the 3 angle bisectors of a triangle indeed intersect at one point in exercise 20. Good luck!